Learn beyond the infinity. Future starts here.
Hello everyone, welcome back to the Quantum Explorer. In today's video, we will discuss about recursion, basics of recursion, what is backtracking, what is base case, and by solving question we will get more understanding of recursion. Let's get started. My name is Popat. So first of all, understand what is recursion. Recursion when a function call itself. Before this video, you must have the knowledge about what is a function, how to write function. This knowledge you must have. When a function call itself until a base condition match. First of all, we understand what it means by a function call itself by an example. Let's say in C++ or in any language. In C++, I talk about C++, you have first of all a main function. Outside the main function, you generate a function which print QE, and inside this function you again call this function. So this is the function calling itself. This is what function calling itself and how it works. In main function, let's say after few lines of code, I call this f function. When compiler come, first of all, compiler come inside the main function, then it's so I call function f. It goes here. Here, what will function do? This function first of all print QE in the output. Let's say output is first output is QE. Next time, again this function call itself. So I again write this function print QE and F. In output again we will see QE. When second time this function will implemented, again in second time this function call itself. Also third time this function will return print QE F, and third time output will be QE. This happened infinitely because we have not base condition. What is base condition? I will tell you later. This is how when a function call itself without base condition, it will turn up to infinite function. Understand the behavior of function by stack, how it works in memory. In memory we have a stack like it. Usually when a function call, it stores in stack, and when it complete its task, means after return something, this function will remove from the stack. But in this example, in this case, function never complete because it not has any return statement. So first of all, first time function will call like that. Second time function again store. Third time repeat this thing. And at the when this memory location will all memory location occupied, after some time it will automatically stop when the all memory location are occupied. To avoid it, we should in function we should write a return statement, or we must end up a function in any function until we give base condition. It will turn up to infinite function. So to avoid it, every time in function we must give a base case to turn recursion meaningful, otherwise it convert into an infinite recursion which is never be useful. For this same example, how I convert it into a recursive program. For this particular example, how I convert it into a recursive program. Now I am writing this same function by just adding a base case which make this function logically correct to implement in the code. First of all, we have this main function. I write function which print count, which I declare a global variable, initially has value 0, and after every time count plus plus. In output, first time the value of count will be written as 0, second time count become 1 and value print 1, third time count become 2 and in output we can see 2. It will turn up to infinitely, not a logical recursion. Why? Because now, till now, it not has any base case. So I must add a base case which make it logically correct. So I add a base case like that: if count equals to 3, return. I will write it properly. Okay. In this function, first of all, compiler come toward this main function. Inside the main function, I call f function. So compiler goes towards this f function. Initially, the value of count is 0. Condition is false. So in output, we see output as 0. When compiler come toward this line, this function is again called and same line of code will again implemented. Means f, here is if condition which is false, count values become 1. Again this function call, in output we see 1. Third time same thing, function called, if condition is false, count value is 2. Now when next time this function is called, if condition become true, because value of count is equals to 3, it means return. How it work, how it looks in stack, in memory. First time when this function is called by main function, it will store in memory like that f. It will first time. When second time it called, in memory it store here. Third time again. Fourth time. And this one is last fifth time. In fifth time, when function completes, it will return, means it come back to fourth time call of the function, means means from the memory this function will be removed. Same way, this function is completed, so fourth time called function come here, third time called function, and this function moves from the memory. Same way, third time function move from the memory, second time, and at the last time function move from the memory. That is how the recursion of this full function works in stacks. This condition at which recursion stops, this condition is called base case. Another term in recursion which usually used is recursion tree. What is recursion tree? For explaining you, I write this kind of function again repeatedly, but not every time. Oftenly we not write like that. We use recursion tree. In recursion tree, let's say first time I call the function, second time I call function, third time I call function, fourth time I call function. When at last after hit base case, this function complete its task, it will again move back. This will complete its task, it will again move back. it will complete its task, again it will move back. In recursion tree, function called, function called, function called, move back, move back, move back. This is the simple recursion tree. By solving one question, we will get more understanding about recursion tree, how to write a recursion code, and the base case. Let's solve a question. Question say that factorial of a number using recursion. We have main function. Outside it, I make of another function called fact. First of all, we should find the base case. What is the base case for this question? Let's say I want to find factorial of 5. What is factorial of 5? 5, 4, 3, 2, 1. What it means? By for any number, when it come to 1, after it must stop. What it means the value of input. When value of input became 1, it will return 1. Then after it will stop and a recursion tree become complete. So how can we write the code for it? First of all, inside this function, we should write the base case. What is base case? If value of given number, let's say number given is n, is equals to 1, return 1. Else return n into factorial fact of n minus 1 means recursion. Understand it by a recursion tree. When first time function called with this 4, inside it condition is false for because 4 is not equal to 1. So this function will return n in means 4 into factorial of 4 minus 1 means 3. Again this same function is called for a value 3. Inside this function, if condition is false, so it will return 3 into factorial of 3 minus 1 means true 2. Again this function called for 2. Inside this 2 is not equals to 1. This condition became false. This function will return 2 into factorial of 1. Again this function called for a parameter 1. Condition became true. So it will return 1, and from here recursion tree moves backward, and this is called backtracking. One will return to the second last time called function, and the value of this becomes 2 into 1 2. This 2 value move again back to this second last time called function, and this value becomes 3 into 2 6. Again this value move back, it becomes 6 into 4 24, and this has become your answer in output. In next videos we will discuss more in depth about recursion. We will solve more questions on recursion.